Good afternoon and welcome to our session, Teaching Statistics Using R to Hospitality Students. Our presenters today are Ashok Singh and Mana Azizsoltani, faculty members at the University of Nevada, Las Vegas. If you have any questions for the presenters during the session, please feel free to enter those into the Q&A section at the bottom of the Zoom room screen, and we will address them at the end of the talk. On that note, I'll hand it on over to our presenters.
Hi there, everybody. My name's Mana, and I'll be starting the presentation. First, I got to figure out how to. Oh, it's not letting me share my screen for some reason. Do you have to give me permission? Oh, okay, never mind. Now it's working. Here we go. Oh, geez. I just need a second to get it set up. Let's see if it works now. Cool. Can you see my screen? Yeah, okay, cool.
We can, yep.
Great, thanks. Let me just go here. Great. So today I'm going to talk a little about our experience teaching statistics using our hospitality students. It's one of those things where it's something that I have passion for. Dr. Singh also has passion for, and it's interesting to be teaching something like that to hospitality students because they're not exactly mathematically inclined in general. So to start out, I want to talk about sort of kind of why statistics and why hospitality. Because hospitality traditionally is one of those subjects where people don't really think of it as somewhere where people need math or need statistics or use analytics. But the truth is that in the industry today, we're seeing a lot of automation and the use of not only just like analytics, but also AI, machine learning, and sort of that kind of those applications to solve problems. So, that's something we see all over the place, not just hospitality. All industries have automation, but in general, we have huge hotels. I mean, we're in Vegas at UNLV, and these hotels, they employ huge teams of people that run numbers, and so there's actually quite a huge need for people that are in analytics. I was part of a panel recently, a student panel for CEOs in the food service industry, and I asked them, I said, well, what kind of analytics solutions are you guys using? And we're jumping over each other to try to say what kind of things they were using. They said that they couldn't even hire enough analysts because a lot of times the people in the students that are graduating from hospitality, they don't have the analytics background, so they have to hire people, data scientists or analysts that don't have the hospitality experience. And so here we are trying to sort of give them that quantitative talent with a hospitality background. So there's definitely like a niche for it. And so that's kind of where we're trying to contribute to the industry by training these people to have the numbers background. Because, it's hard to find that person that has the analytical background, but also has the hospitality personality and the interest and that kind of stuff. But it's also really hard to find that hospitality student that has all those soft skills, that knows the industry, that also has the analytics. So here we are trying to merge those two worlds together, and it can be challenging at times. So I want to talk about your typical hospitality student. See, I'm a PhD student in hospitality, but my background is in math. I have an undergrad in math and a master's in statistics, so I don't really fit this mold. But the truth is, even at the PhD level, a lot of my colleagues, they kind of fit the hospitality student mold. These are fantastic students that have amazing people skills. They're always open to change. They're dynamic. They think on their feet. I mean, these students, they have a different skill set. But when it comes to math and statistics and numbers, they actually have a lot of issues. They're the typical student that says, oh, well, I'm taking, at UNLV, we have a requirement for math is actually college algebra. So even at the level of college algebra, they say, oh, why is all this important? I'm in hospitality, like, I don't need this. I don't need to know this. And more on that later. And they also have like high levels of math anxiety. It's been proven in many articles, studies that show that hospitality students actually, so hospitality considers itself part of the social sciences, and so as a social science, it shows that it's been proven that social science students have very high levels of math anxiety, and that comes from the fact that I think something like 75% of social science majors have not taken math since age 16 when they start school. They're not gonna, senior year comes around in high school and they say, oh, I'm gonna study sociology. They say, oh, I don't need to take calculus, or I don't need to take the higher level math classes. And so that kind of contributes to the math anxiety. Similarly, they also have low math confidence and low math joy. They don't really enjoy it. And on the same lines, they also have very little math background. Like I said, they don't really take those classes beyond algebra, and in college they're not even required to, so it doesn't really make sense for them to do it. A little bit more on like the why this is important. This kind of came about. I have a podcast that I record called the Job Forum, and I bring in recent graduates of different disciplines to talk about sort of their journey through college into the workforce. And I brought in a couple of hospitality students, one in events and one in culinary, working in the restaurant industry. And they both said that, if they could go back and do it over again, what they would tell themselves is to pay attention to math classes, pay attention to numbers classes, because they actually use that stuff almost every day. So there's definitely a need for it, but the problem is the challenge is the students' mentality, because you require the hospitality students to take the finance classes. They'll take them, but that doesn't mean they're going to like them. Doesn't mean they're going to pay attention. Doesn't mean they're going to internalize the information. So that's another challenge that we have to address when it comes to teaching statistics and hospitality. No. Oh, there we go. Okay. And so I want to ground sort of this idea of teaching statistics and hospitality into these three learning theories. As educators, you guys are probably very familiar with these, so I'll just touch on them briefly. But first is Constructivism, which sort of talks about how the learner builds on their previous knowledge, their previous experiences, that knowledge is constructed, and that, if I talk to you about statistics all day long, you're not going to internalize it unless you can connect it to what you already know. And so I think that's a big key for hospitality, because we need to look at statistics in hospitality as in statistics connected to hospitality. We can't just teach them statistical theory or the models or programming. And it has to be set within a framework that is hospitality, so these students can connect it to what they already know. And then it also says that learning is an active and social process. There's social constructivism and also cognitive constructivism. And so in order for us to be able to learn, we have to be able to be engaged and bounce ideas off of others. And I think that's really key when it comes to statistics, because in the classroom, we try to sort of give it equal power between the students and the instructors, so we can work through the problems together actively and engage the students. So next we'll talk about transformative learning. Now I think this particular subject, statistics and hospitality, is a very good, it almost like sets a perfect framework for transformative learning, because these students already have this conception of math. They don't like it. They're not confident about it. And so bringing them through that, sort of taking them over the hill, is like perfect for their transformation, so I believe change plus critical reflection leads to learning. So if we can convince these kids that you can do it, and it's possible, and it's honestly interesting to solve these problems using data, using numbers, if we can convince them that that's true, which sometimes is difficult, then we get them to critically reflect that, like, I was able to do this. I went through the problem and it was awesome. And so that can definitely, that's where learning comes. You see all the aha moments from the students, and it's really awesome to see someone that, at the beginning of the semester, they didn't necessarily believe in themselves, and at the end they can do the analysis, and they'll bring the data in themselves. They want to look at something that they came up with in work. They want to talk to their supervisor, blah, blah, blah. It's really awesome. I think that change is definitely one of the most satisfying things to see as a teacher. Then lastly is the multimedia learning aspect of it. Where once maybe statistics was taught with pencil and paper, crunching the numbers. In fact, I've actually had a couple classes in my PhD which I had to do something like that. It just doesn't make sense. We want to use software. We want to use the multimedia. We want to make sure that students are getting the information through the auditory and visual channels, so that way they can merge that with what they already know to build new knowledge. So the tool we use is R, and I'll talk more about R later. Has great capabilities for that, visual data visualization, and also it has different capabilities for teaching actually. So I'll probably have Dr. Singh do a little demonstration about that towards the end. So first, constructivism. I touched on it a little bit, but I'll go into it a little bit more, just so I can kind of establish that. So, like I said, knowledge is not transferred; it's actually constructed. So you build it based on previous knowledge, cognitive versus social. Learning is a social activity that to bounce ideas off each other, to learn together. It's nice in the classroom. Spend a lot of time walking around and making sure the students are working together, and try not to. I try to let all the students do working groups, so that way they can bounce the ideas off each other, learn from each other. There's always going to be someone that's better with the computer, gets it more than other people, and they can always explain it. And plus, when they explain it, they learn it. And so, like I said, builds upon existing knowledge, and that the learning is inquiry and problem based. So the way we like to teach it is to have the students inquire about a problem, in hospitality, or present them with a problem and have them work through it. And doing this, they can be actively engaged in the problem. They can bring in their different backgrounds, their different hospitality backgrounds, because at the UNLV Hospitality College, we require the students to work during their degree. So they can bring in their different experiences into the classroom and into their learning to solve the problem using the data. And so talking about the 5 E's is a kind of a learning model that we try to use. It's been applied all across different areas. Engage, explore, explain, elaborate, and evaluate. So you engage the students in a situation. You have them explore the phenomenon. Challenge their prior knowledge, help them create the ideas, and then have them explain what's going on. That's part of looking at the data, understanding what exactly is the problem, what are we trying to look at. Next is elaborate. We elaborate more on the issue, apply their knowledge towards new situations, and have them deepen their knowledge. Then last is obviously evaluate, have them reflect on what they did. That could be looking at the output of the model. That could be kind of applying that to the actual business problem itself. So that's kind of where the constructivism part comes into the classroom. Very important. Next is transformational learning theory, started by Meisro in 1997. Like I said, the whole learning statistics and using math and hospitality is a very disorienting dilemma for them. So that's often where it starts. So they have that dilemma, and then they say, oh, well, can I even do this? And and then we sit down and we tell them okay, let's look at the problem. Let's look at what's going on. And that kind of goes into the critical assessment, the recognition that maybe we could do this, the exploration of the problem. And so then I guide them through the different, what they could do with the data, what they could do with the problem, how they can solve it, what's possible in R. And so then we, provide the new knowledge for them, and then tell them, like, solve the problem. You guys are the analysts, you guys are the data scientists, like, you guys can do this, and they go through and they do it, and they realize, wow, this is not that bad. This is actually interesting, and let's solve some problems. And it's always really awesome to see. And one of those key things is that after, you have to make them realize, like, wow, like, it wasn't so bad, and it's like a very, very sort of, for them to have them change their perspective on math is just like, kind of, it's almost me doing my job. I feel like, just if I can get them to look at it in a different way, in a positive way, instead of trying to avoid it. So let's see. Okay, next, lastly, multimedia learning theory. One of the pioneer of it is Richard E. Meyer. Talk about how people learn deeply through words and pictures, and in fact, the multimedia principle, that people learn through words and pictures instead of just pictures alone, or just words alone, which is kind of why this PowerPoint is, why do PowerPoints, the pictures and the words together on the screen, plus me rambling on will help you learn. And so, the two channels, auditory and visual. So words and pictures are presented, and then our eyes and ears pick them up. It's in our working, and then we put it in our working memory, where we create, we'll put together the information, process the information, and then in order to get it out of our working memory into our long-term memory, which our learning, we have to combine it with our prior knowledge, which Constructivism. So it's all kind of intertwined in that way. And so the thing is like, the working memory has limited capacity, so we have to be careful not to overwhelm the students with tons and tons and tons of data and numbers and math, and just go little by little and have them process it in chunks. So now we'll go into the bread and butter of what exactly is R. Well, R is a programming language. It's an environment. It's a statistical computation modeling tool, and it's also a data visualization tool. R is actually the, sixth or seventh most used language in programming language, period. It has its pros, has its cons, but it's up there with the most popular. Next, it's also an environment. So an environment means that instead of just being a software, it also, like, that's a picture of RStudio on there, that you can program, you can see the graphs, you can see the code, everything's integrated.
Write the report.
Right, you can even write a report. And then it's also a statistical computation and modeling tool, has all kind of programs built, it has all kind of models built into it, excuse me. You can do basically anything in R, and it's constantly being updated, which I'll touch on a little bit more in the next slide. And then obviously it's an amazing graphical tool. ggplot is one of the most used packages. It's one of the best tools that there is out there for creating data, or creating data visualizations. This is actually, the picture right here is actually a picture that I made for one of my classes. It's red wine and white wine, actually, distributions. And so I was able to pick the colors of red wine and white wine out. In another one, I was able to use, instead of points, the little wine glass. So there's a lot of different creative things you can do with R. So there's three different ways you can use R. One is R console, which is just kind of like bare bones R, where you imagine you just like typing into the terminal, like code sort of, which you can also integrate into RStudio, which is basically like a nice way for the user to use it, where you can see the graphs there, you can see all the stuff that you have in the working memory, you have everything. You can have the R console on the bottom. You can write code and save it and all that kind of stuff. Let's see. R language asked for in jobs. Sorry, I just saw your question now. Yeah, R is a language that is asked for in jobs. I'm actually in I take this political science class, and this semester it's mostly just a stats class that they do through the political science degree. And at the very beginning of the semester, the professor posted a graphic where it was, like, what are the it was like a study of the different job, like entry-level jobs out of a degree in like analytics. And it had up there the two most important ones, like the two most asked for skills were Python and R. So hopefully that answers your question. And then, so keep going through this. So there's RStudio, and there's also R Commander, which is very similar to, for example, SPSS, where it's just a point and click kind of way to do it. R Commander is good, but it's a little clunky. It's not as flexible, and but it is a little bit easier to learn because it's just, you know, students are used to just the point and click kind of way to go. So anyway, let's see. Okay, so why R? So like I said, there's other options out there, like SPSS is used very heavily in the social sciences. There's Data, which is also used in kind of business context. Minitab also, which is good. It's kind of more like Excel, with has like you see the data in there and do the different. And there's also Excel, of course. But the nice part about R is that it's free and open source. And so what does that mean? Well, open source means that anyone can contribute to it. So it's not a proprietary software. It's kind of sort of community built, community owned. And so kind of because of that, there's a huge community of people in R. Any question that you have can be answered on the internet, especially for a beginner. I know the students really like that, where they can, if they have a problem, they can like copy and paste the error code into the internet, and boom, someone has an answer for it. Or, oh, I'm trying to do this, boom, someone already did it and they have an answer for it. Where you can just copy and paste the code in there, edit a little bit, and have everything worked out. Next, that also means that there's infinite packages. People are always creating a new package for R, which means a new statistical model, which means a new way of doing the modeling, more efficient. And then those packages are also moderated by people or scholars. So they're always evolving with the times. Let's say, like, for example, there's a new statistical technique that was created for modeling, I don't know, qualitative data. Well, some guy in R is going to create a package, and they're going to keep it up to date with the statistical theory that's coming out. So that's kind of the beauty of it. That's always up to date. Whereas, for example, with SPSS, you know, you only have a certain amount of functions that you can click, and then until SPSS puts out the next update, you know, you don't have anything.
There is one more issue with using. I won't say that with SAS. SAS is pretty advanced, but like any window-based software, there are two issues with them. One is that after you have run through a data set, you don't know which data file you use. But if you use R, the code has the name of the data file, so you know which data file was used. And there is another issue with the commercial packages. They cannot keep up with the advancement of statistics, or, you know, for example, machine learning does pace. They cannot keep up with it. R does. You could be using a package developed yesterday, and I have used those packages because they're taking, you know, the state of the art and keep pushing it further out. That's you know, the commercial packages cannot keep up.
And not only that, but the commercial packages are extremely expensive. I think for students, I mean, for students, they have to pay, you know, if the university doesn't provide them, they have to buy it on their own computer through distance education or whatever. I remember one time I had to buy SPSS for one of my summer classes when I was younger, and it cost me like $60. But whereas R is free and has much more capabilities, more flexible. I mean, it killed me to pay those, you know, $60. But, you know, you had to do it for a class. And then the last part I want to also mention is that it's markdown capability. So actually, you'll see later when Dr. Singh does the demonstration in a second, he actually uses our markdown capability, which is basically being able to put code and output into a file for reporting purposes. So like I said, the biggest challenge with R is you know, the steep learning curve for people that don't know that much about statistics. And so in the classroom, we have to spend a little bit more time talking about computer, you know, how to with a computer. Like some students don't even know how file structure works, or you have to teach the basics of programming, which is, you know, how to set a working directory, how to, write, how to add in R, and just basic stuff like that. So definitely, we have to start the semester pretty slow and then ramp up. But the truth is once you get over that initial learning curve, the rest is really easy, and you can just pick up the skills like this, and then you have access, to everything at your fingertips. And it also must have computer access. So we usually do the lesson in a classroom, like a computer lab. You can't see the computers in there, but they come up from the little desks in there. And so we've been experimenting lately with teaching it online. There's me right there teaching. All right, I walk through the problems with the students, and yeah, I mean, the beauty of it is that you have to implement it into the classroom, and you have to be really, really patient with the students, because they don't know, and you have to I walk around and make sure that they're learning, and I try to address the problems. Beginning of the semester, it's always rough because they can't figure out like how to download it, how to load data in, we have to start slow. But with hospitality examples, they're interested, they want to figure it out. A lot of them are into, they know about data science is trendy, and they want to learn. So patience. Like I can't even stress it enough. If one thing I learned from Dr. Singh is that you got to be patient with the students. You have to be. And so the objective of the course is promote statistical thinking. I mean, a lot of times they're not going to learn the statistical models. They're not going to learn they're not going to remember like the nitty gritty theories. They're not going to remember even the distributions. But what they will learn is that it's possible to solve these problems with data driven, make the data driven decisions to solve the problems, not just try to make a judgment. That they can actually work through a problem using the numbers, using the data, using the statistics. And so that's kind of like the goal. And then also like the analysis and visualization, we want them to be able to analyze data and also create meaningful interpretations of data. So that means also like, creating a graph to show the distribution of, let's say, I don't know, revenue in a hotel over time. And then they can be able to explain that to someone that doesn't know anything about data, the most basic level. And then also basic programming. So once you have to start somewhere with programming, and once you learn, then if students learn the basics in our class, and if they want to pursue analytics later, they can learn more or learn less, and so on and so forth. Let me just make sure that, okay. So before we end, I'm going to have Dr. Singh right now give a little demonstration of the central limit theorem demonstration package they have in R, just so you can see like the teaching power that R has. So let's see if I can share my screen. Okay, let me just put this away, and can I go into reader mode? Here we go. It's bigger. Okay.
Before I go over this,
and sorry, and
no, you can just use I think you can just use this. Okay.
hello, can you all hear me?
Yes, we can hear you. Thank you.
Okay, great. So before I go over this, the central limit theorem demonstration, which is central actually to teaching of statistics, simply because when we go into statistical inference, like confidence interval estimation or testing hypotheses or multiple linear regression problems, including analysis of variance, testing for proportions, the chi-square test, everything involves the central limit theorem. But I would just like to talk about my experience with teaching of statistics also. So this started, I used to use SPSS initially, but then SPSS is a little non-intuitive for me. And some of the output, I saw, I wasn't really agreeing with the way they were outputting the results. So I switched to Minitab, and it's very easy to use and all, but the problem, as I said, it's expensive. Plus, you really don't know what data went into the analysis and so on. But I was using Minitab up to 2019. But then right after COVID, when I had to teach online, I decided to switch to R because it's free. I did not want students to have to buy software, even though it's only 25 bucks or 50 bucks. I didn't think it was fair, especially in COVID, because you can go to work. Some students, don't make enough money. So I switched to R, and I was really apprehensive about it. How would it go? And the students really surprised me. They had more patience than I had. So they kept plugging at it. The first couple of weeks were hard, but once they picked it up, they enjoyed it. And there's something else that online teaching taught me. It's more interactive than in-person class. The reason is if somebody is having a problem, and I encourage them to ask as we go along. So they will ask, this code is not working, there's something wrong. Then they have to share their screen, and the whole class, I don't help. The whole class is helping. So everybody is learning. And if the class cannot help, and sometimes I've made a boo-boo, I will see it and I will fix that. So it really is, like it opened my eyes teaching online, especially this class, like stats class or machine learning class. It's a lot easier to teach because it makes it interactive. The internet makes it interactive. So everybody joins in. One problem is, of course, there will always be some shy students. So I give them, it becomes more work for the instructor, but they have my cell phone and they can text me or call me. And I have met students, online at 11 p.m. or 6 a.m. whenever they can, because Las Vegas students are not typical students. They may be working night shift. They may be working first thing in the morning. Most of them are working outside. Some, of course, are graduate students like Mana here, but not everybody has that money, that support. So, okay, so let's go through this central limit theorem demo. This will show you how easy it is to demonstrate this concept of central limit theorem using R. What I may do is, so this was done in R Studio. So R Studio is a front end, as Mana explained. So how do we scroll? Just stop right there. So what we are doing here is, because central limit theorem, we're demonstrating how central limit theorem works. So let me just tell you briefly what central limit theorem is. It says that the distribution, probability distribution of the sample mean of n observations will approach normality, the bell-shaped curve or the Gaussian curve, if the sample size is large. And there's one more thing that we should know. You should know is that if the underlying population is symmetric, does not have to be normal. You only need like 5 or 6 samples, and the distribution of X bar would look like normal. So here in this code, we are running 4 sample sizes. Sample size 1, so that you're just getting a sample of size 1,000 times, and then computing the sample mean and plotting the distribution, then increased it to 6, 60, and then 120. So in any simulation, you want to be able to reproduce your results, so that line that says set.c is equals some large integer is simply, if you run it again and again, you will get the same random numbers. So you can reproduce your results later. So here, so this is the power of R. So the next line that says X is a matrix of R unif generates the uniform random numbers. So N1 times 1,000. So let's say I'm using N4 of 120. It's going to generate 120,000 observations from uniform. the distribution has a minimum of 0 and a maximum of 10. And then I start this n row of n1. So let's say the sample size was 120. So what is going on is takes the entire length of 120,000 observations and makes that into a matrix. So number of rows is sample size. So you have 120 rows here and 1,000 columns. The columns are the iteration in the simulation and rows are your samples. So then just go up just a second. No, it's okay, right there. So the next code that says X bar is equal to, sorry, I need to, Mana is telling me to go fast or shut up. So I'm going to shut up very soon. So X bar is, when you say apply, it takes the data frame X1, the 2 is by row, 2 is by column. So the columns are here, computing the mean of each sample. So X bar 1 becomes, column of sample means. Then we are just plotting the histogram. So you can see that as the sample size increases, this is sample size 1 from uniform, then go to the other one. This is sample of size, no, 6. Yeah, sample of size 6. And now you can see that it's looking like a normal distribution. And this is known in mathematical statistics that if you want to generate normal distribution data cheaply, all you do is take a sample of size 6 from uniform and compute the sample mean. That sample mean will be Gaussian. So that's the rest of it. I just wanted to go really, yeah, it becomes more and more normal looking. But one thing I wanted to point out was, again, the power of statistics. So there is a package. Oops. Sorry. There is a package called teaching demo. So that will do this simulation from different distributions. I only wrote the code for uniform, but if you go to the very, yeah, it's just that one code. So you load the library, teaching demos, and all you have to do is a CLT exam, one line will produce these 4 graphs. What is going on is if the underlying distribution is normal, you will get a normally, that's theoretical result. If it's a gamma distribution is skewed, positively skewed. So if you increase the sample size, this is a small sample, if you go up, yeah, see, this is sample of 30. You can see that even for gamma, it looks like normal. Beta distribution is restricted to the range of 0, 1, and it's asymmetric, it's not symmetric at all, depending on the parameters, but it becomes distribution of X bar becomes symmetric. That's all I wanted to talk about. But it's just, R is hard to learn, but once you learn it, you will have that edge, especially if you are studying hospitality. Because very few people in at least hospitality would have heard about it. Thank you.
So yeah, thank you very much for listening to the presentation and following along with us for teaching statistics to hospitality students in R. Any questions? How do you do testing? So to do testing, you can run one line of code, just like we had on the other thing where you can produce, for example, the simulation with one line of code. They have also just functions in R where you can put like t.test, do a t-test. Yeah. You can do, you can do anything from ANOVA, t-test, chi-squared test, anything. That's the beauty of R.
Everything is just one line code.
How do you test your students? How do you test the students?
Okay, the students are tested by working with each other on projects, statistical projects. So that basically becomes their report. So they have to collaborate on that. So they're learning three things. One, they're learning how to write, which is really crucial. And then also learning how to collaborate, which is also very, very crucial. Lots of faculty they have trouble with interacting with people, and this teaches them already.
And not only that, but in the industry, when they go, if they do choose to work in analytics, they're always going to be working on a team, and they're always going to have to explain the data, their results to people that don't know anything about numbers. And so that's a very crucial part of learning.
So the grading is from the, you grade the
Project-based.
final project based. So I really do not like people to memorize the code or memorize the formulas or anything like that, because that's not the world we live in anymore.
Yeah.
If you go to work, they will give you time. It's not like a race that finishes 2 seconds.
Well, no, I've been using R for like 7 years now or something like that, and I still have to Google, certain things.
I mean,
because,
I've been teaching a lot longer.
Yeah.
I have to Google sometimes. It's a tool. Google has become a tool, and we use it.
And it makes our life a lot easier.
It does. It does.
Any other questions?
Well, it looks like we're just about at time, so that works.
Perfect.
Great. Thank you, Dr. Ashok Singh and Mana Azizsoltani, for all the valuable information you shared with us today.
Thank you.
Really, it was great. Thank you.
Thank you so much.
And the next current sessions will begin at 3 p.m. Eastern Standard. You can view the chat for session meeting room links or access the conference website for a complete list of concurrent sessions and their descriptions. While accessing the conference website, don't forget to swing by the virtual exhibit hall to say hello to our Hawks team. While there, you can view a quick 5-minute demonstration, request your t-shirt, and be entered to win a $50 hourly giveaway. Also, in the spirit of St. Patrick's Day, you'll find a few golden coins throughout the conference website. Click on the coins to be entered for a chance to win an additional raffle. We'll see you at the next session. Thanks again so much, everyone.